Greetings, everybody. This is Keenan once again, and our journey continues with Rhino. This time, a little different approach. We're going to be using CAD Mapper, which is a sort of free, open source website to create maps, 3D terrain data, and often fairly accurate building data for urban scale sort of projects. You may have used this program before. If not, it is free to use. I think that just limits you on the scale and size that you can export. But up to 1 kilometer squared, that's plenty for most people. So I've already an account, but you're welcome to create one and create this new drawing. We're going to be using the Nob Hill location for Albuquerque. I wish sometimes was California, right? So we're going to focus here, and you'll probably see this little triangular lot at the intersection of Girard and Central. And so this is kind of the area that we're going to be using real roughly. So CAD Mapper works super simply by just, you can click and drag an area. Oh, sorry, not click and drag, but click and then opposite click an area here to define this sort of area. And we'll just somewhat generally center that triangle lot in the middle. And then that's our selection, right? And you can, of course, clear that and edit it in other ways. But that defines our region that we're wanting to get the 3D terrain data from, the streets and building heights, etc. Now, on the left-hand side here, we'll see under Create Map, we can export this in a variety of file types. The Rhino 5 is great because we're going to be using Rhino. However, oh, my cat's in the background wanting some attention. However, if you were using Illustrator just for 2D stuff, or if you needed it as a DXF file, AutoCAD Exchange file, you can select those. But if you're going into Rhino, just make sure it's Rhino. Here's some other options, right? You've got 3D buildings if available. Now this can be a little dangerous. This box here, set false height if no 3D data available. I think we kind of want to, well, it depends on the scale and accuracy of your project. If you're just going for representational stuff, that's probably fine. For the most stuff that I would do, I would probably not want to use a false height or find a way of getting a more accurate height from existing buildings. Anyway, and then the topography. So we do want to include that. There's not a whole lot of slope going on in this area, but we want to show some of it. And then you can change your contour intervals. And again, these are all in meters, so just be aware of that. We'll talk a little bit more about that as we go forward. But for the brief times that I've used this, it seems to just default to metric system measurements, which is fine. But if you're doing feet and inches, then you'll just have to convert it. And we'll show how to get the proper scale in Rhino later. Under road geometry, you have a few options. You can either use the center line of roads, the outlines, or mesh surfaces. Depends on what you're kind of going for. I think outlines is fine. Now, it does approximate this. It's not truly accurate. It's here you get your sort of hierarchy of roads, right? Highways, major, minor paths, and it just gives an arbitrary width for those outlines. And that's not going to be accurate for everything. It'll be approximate, but just don't be asking for it to do more than it can. And I probably wouldn't recommend using mesh surfaces unless you really need the actual surface of those streets. This might just bug the model out a little too much. So outlines is fine. And then we're going to go ahead and download that. Go create file. Now, like any good chef, I've prepared an example in advance, so we don't have to wait for this whole area. But you get a little preview, which is great. You can do a 2D view. Topography. It gives you just like a little height field. I've got one contour line here at 5 meter increments. So yeah, I mean, 5 meters, that's a lot. It's like over 15 feet. So, Anyway, so to download this, you just go ahead and download. And I'll go ahead and do this just to show you the whole workflow. I'm just going to put this in my downloads folder, save that. Okay, great. And we'll close that. And we'll close this Chrome tab. Okay, so you'll want to open up Rhino if you don't already have it open. Now, when you first open Rhino, or if you create a new file, it will often prompt you for a template. And this is really defining the scale and units of your project. So for our new file, we're going to be using most of the time, in America, doing our feet and inches. I would prefer if we all switch to the metric system, just make our lives easier. But that's the world we live in. So we're going to choose large objects, and you have several versions of this. There's feet and inches, and then there's just feet. The feet and inches just defines the distance measurements, which you can always change later. So I think I would just recommend the generic sort of feet template type, and then just say open. And now at the bottom, you'll notice our units will be in feet, and we have some default layers here. Okay, so to import this CAD Mapper file into Rhino, first we're going to go ahead and find this file real quick. I'll just bring it over. Okay, so here's my downloads. It's going to come in as a zipped file, so you're just going to want to go ahead and extract that zipped file. So we'll do extract all, extract, and that's just going to uncompress all those files in the CAD Mapper. So if we go into this folder now, we'll see we have our Rhino file, the CAD Mapper, Albuquerque, New Mexico, and then we will have some license agreement stuff, so no problem there. So this comes in directly as a Rhino file. Now we could just straight up open that in Rhino, and in fact I think that's what we'll do. We're just going to compare the units here and make sure that if we go back to our other new file, we're using the correct units. So this is a great way to be able to verify that we have our scale correct. So with this file open, you can see we've got this wireframe preview. Again, if you wanted to change this to our shaded view for everything, go up to this gray sphere, go to the little drop-down arrow, and your first gray sphere is your shaded viewport. Go ahead and right-click that, and it'll shade all of these viewports simultaneously. And yeah, so you've got this little chunk of Knob Hill. Okay, so right off the bat, we're going to look down here next to our layers pop-up, and we are indeed in meters. Okay, so this is important to remember. Rhino will save the units that that file is generated in, and it's important to know if you open a file in our feet model units, then we will have to go through a scale option to make sure we're scaling this correctly. Okay, so this is just to verify that it does indeed, CAD Mapper does indeed generate these files from a metric unit of measurement. And also, I'm just noticing, because I unselected that generate false 3D data for building heights, there's only 4 buildings here that actually have verified building height data. And this is actually a good thing, but for at least this demo. Might not be a good thing for all projects. If we had downloaded that CAD Mapper file and instead, if I can go back here, if we had set false height, if no 3D data is available to this sort of random number of 3 meters, that would give us a starting point, but it would be very difficult to verify if that's correct or not without further investigation. Luckily, we do have, from Tony, thanks to Tony, we have a building height reference guide that you can find in our shared OneDrive folder. It should be called Knob Hill and Hojo Center Building Heights, something to that effect. And if you go ahead and download that and open it, it should look something like this. So we do have some building heights that we can reference to be able to generate some building heights that are somewhat accurate from this generic CAD Mapper file. So I'm just going to minimize that for now, minimize this for now, and yeah, so really we just wanted to open this to confirm that the meters were what the units were generated in. We're going to go ahead and close this now. Going to go back to our new project that we created. I had 2 different versions of Rhino open. So we're going to verify we're in feet, so that's good. Now, to import that CAD Mapper file, you can import a variety of file types into Rhino. Of course, you can import an existing Rhino file. And just for reference, if you're looking through your files, I'll just bring this up, you'll see the extension, the file extension type, the .3dm. That's a pretty common object file, but specifically for Rhino, that is what Rhino saves its files as. So if you ever see a .3dm, you know that that's either been generated in Rhino natively or been exported as a .3dm. Okay, great. So back to our feet, our new units are in feet. Our new project file is here. So to import files, we're going to go to File, Import, and you'll see it. We've got a whole bunch of stuff. I do a lot of 3D printing, so here's my AA battery holder for some reason. A lot of fun stuff. So I'm going to go to my downloads, and we're going to CAD Mapper within that extracted folder, and then here's our Rhino file. So I'm going to click Import, or click Open, select the file, Open. Before I do that, here's just all the different file types you can import. So there's quite a lot. You can do AutoCAD directly. You can do the DXF, the AutoCAD Exchange file, OBJ, objects, SketchUp files, scalable vector graphics, SVG. So a whole bunch of stuff. It's a pretty versatile program in that sense. But I'm just going to go ahead and select that, go Open. Okay, so now if all goes well, we shouldn't need to do any scaling, but let's just confirm that we've actually scaled this correctly. Okay, so, we're going to look at this building over here. So this is our, getting my bearings. Yeah, this is our triangle park here. This is our large building that does have a fairly accurate building height. And before we go any further, I'll just go ahead and double click to get 4View, shade all my viewports. Okay, so this is going to be our sort of litmus test to see if we've scaled this, or see if there's any trouble importing or scaling things. And I'm actually, for this, I'm going to turn in ghosted, because if you'll notice, I'm just going to zoom selected on this one. If you notice, the 3D surface that's defining our topography is clipping into our building a little bit. So depending on how this CAD Mapper, how accurate that has been generated, building footprints may be clipping into the surface. So bringing up our photo just for a second. That building that we're looking at is going to be this one here, right? It's got our triangle park, we've got a few of these little stragglers, and then we've got like a 25-foot thing. So it's like a pretty typical 2-story commercial building. So we expect this building to be about 25 feet high. To confirm that, we're going to use the distance command, and I really love this command. I use it all the time. So we can type in distance, and we're going to snap to the bottom point of our building. That'll be our start point to measure, and then our end point will be the top there. And I'll just click, and then you'll see up here at the top it'll say distance equals 19.69 feet. So yeah, this is roughly scaled correctly. I think the CAD Mapper files are, there's enough inaccuracy in the building heights that this is kind of to be expected. And then you can see, like, for the majority of these buildings, we don't have any information on accurate heights. And let's go back to that image. Let's look at this building just to kind of get one more point of reference. Make sure we brought this in right. So looking at the image, it's going to be about 22 feet. So let's do the same thing. We'll do distance. And again, using ghosted viewport, you can see through these surfaces and find those points. So start and end. Yeah, this is like 19.6 feet. That's more or less the correct scale. So I think I can pretty confidently say we've scaled this, well, we don't need to do any scaling for this. However, I'll show you one method. So if you wanted to change the units of our model, so we're in feet right now, right? Maybe we wanted to go back to metric because we decided that the metric system should just be our default. And that's great. I'm all here for it. Let's type in the command units. Pretty intuitive, right? Units. Enter. All right. Now this will display the current model units. And if we wanted to change it to feet to meters, we would just select meters from the drop-down here. And then we would say, OK. Now, Rhino 8 may differ slightly for this pop-up menu. As we found in class, you want to select the second option if there's multiple options for Rhino 8, where it says something to the effect of, we will be scaling this model so that 1 foot, in this case, equals a certain decimal equivalent of meters. And you can kind of read the fine print there, but it basically says we want to scale that so that it's correctly. And in Rhino 7, the pop-up looks like this. So, change from foot to meters. Should we scale the model by this scale factor? And this is the conversion rate, basically, between our feet and meters. So in Rhino 7, we'll click yes. In Rhino 8, you'll choose the second option of those 2 options that you get in this command. So we'll say yes. Now you'll notice that it's kind of shrunk down. But we can confirm that this is correct by measuring, let's measure the same building that we've been measuring. So we know from our image, it should be roughly like 20-some feet. I think this one, that was like 22 feet. So in meters, that would be, a meter is roughly 3 feet. So we would expect that, should be roughly an 8 meter or 6, between 6 and 8 meter building. So as long as you're not off by an order of magnitude, like if this says like 1 meter or 0.5 meters, then you've scaled correctly. So you can switch between units at any time. You just have to be careful that you check that option to scale your model so that it's not just ignoring that scale factor, right? So I'm going to go back to feet for this because we have all of our building heights in feet. So I'll say feet and then click OK. And then in this case, now I'm going from meter to foot. So scale model by 3.28. That's the conversion rate, right? So we'll say yes. All right, now we're back to feet. Okay, so hopefully that gives you some idea of how to scale or how to confirm the units are correct and how to change scale if you need to. Okay, so first step, I'm gonna change some colors of these layers. So the buildings, I'm gonna make maybe like an orange, and you just do that by clicking that default color square. And looks like park, might as well make that green. How about a sea green? And you can see that's just this line, this triangular line, right? So it's not filling that with a surface. And I'm curious actually what this layer is. That's on an outline layer. I believe that's going to be the street outlines from CAD Mapper. So let's go ahead and change that to this sort of reddish brown. Oof, actually that's pretty terrible. Let's do let's do cyan. Yeah, that's okay. I mean, have fun with it. Just looking for something with a little more contrast. I'll go to a darker, maybe this turquoise. Yeah, there we go. That's looking slightly better. Yeah, it's truly up to you. And then our contours, I think we only have one. So let's do like red maybe. Okay, we have like 1.5, these two little lines. And then we have our topography surface. I'll go ahead and make this like, maybe we'll do that as our, well, so many colors, right? We'll do a light sort of lavender blue. Oof, I don't know. Yeah, let's put our street outline back to black. I think that's fine. Okay, so just something high contrast so we can kind of see what's going on here. Alrighty, so I'm gonna see if I can pull up this image real quick. And we'll zoom out just a tad just so we can sort of see both of these things at once, and I'll see if I can do this. Okay. So just want to be able to see my building heights and use Rhino at the same time. Alrighty, so if we were very confident that these building heights were correct, which I feel like Google Earth Pro should be a little bit more correct than maybe CAD Mapper's open source. I don't exactly know where it gets its building height data. So if we wanted to start by just scaling these to be more or less correct with our Google Earth image height building heights, we're going to use the scale 1D command to quickly change the vertical height of our buildings. So I'm going to type in scale, and there it's already there, scale 1D, and 1D for one direction. The command works by specifying a base point, and this will be the point that's on the ground or in the ground. So we'll click that, and now it'll ask for either a scale factor or a first reference point. We're going to be using the reference point, so we're going to go ahead and click the top of this building here. And then now we can see by moving our mouse up and down, we can change this vertical scale in one dimension. So this next point of the command is saying second reference point. So we could either, if there was another object that we were referencing and wanted to go snap to that height, or like maybe the midpoint of something else, we could do that. Or what I think is easiest is to enter the dimension that you want this these two reference points to be. So we're going to go look at our image. It's going to be 25 feet for this higher one. And this building footprint is drastically simplified, right? We can see that this is actually made up of a series of connected buildings with different heights. One's at 15, 22, 21. We're going to average this, and we're just going to pick that 25 feet. So I'll type in 25. Because my units are in feet, I don't need to add any unit specificity. And I'm just going to press enter. Excuse me. Oh, I had a little backslash that snuck in there. 25, enter. Okay, there we go. If you're ever looking at your command line, you can kind of drag this a little bit. You can see this history, unknown command, 25. I just had a little backslash typo there, so that's why it didn't complete. So anyway, that can give you some information if you're like, why is this command not working? It'll tell you, oh, there's a little typo. So anyway, there you go. Great, so we've got our 25-foot scale 1D building. We'll go ahead and do the same thing for this other building here. I'm just going to zoom over to this scale 1D. Now, this one's a little shorter. It seems to be 22 feet, so we'll go ahead and do 22. All right. Okay, so for the rest of these, I guess we have one more, and I'm not sure. This is outside of our little Google image, so we're not going to worry about that one. But we could start extruding some of these other buildings that we would like to have extruded. Okay, so we're gonna just use the ExtrudeCrv command like we did in the previous tutorial. So ExtrudeCrv, and now go ahead and make sure. Oh, now this is where things get interesting. Okay, I'm gonna cancel that. So I kind of assumed that these lines were closed, but I have a feeling they're not. Oh, maybe it isn't. Okay, it could be closed, but it might not be coplanar. Let's just try this one more time. ExtrudeCrv. Solid. Yeah. See, it's going to be creating this shell, and I'm just going to see if CAD is going to work. No. Okay, so CAD Mapper's building footprints are a little bit messy. Basically, what's happening here is this line, it is closed curve, so we can see from the properties. However, it is not planar, so it has some variation in the Z height. We could do our ProjectToCPlane command, and then in this case, we will delete the input just so we don't get confused. And yeah, you can see it was kind of floating, floating on that surface and probably getting a little bit of 3D data mixed in. So we could not, in that case, use ExtrudeCrv. ExtrudeCrv needs a planar closed curve in order to generate a solid form. So that's one of the downfalls of using these. And this is if we really want it to be accurate. I think if we were okay with the variations in building height, we could go and create that CAD Mapper file and just say, for all the, in our options with that generate, going back here, set false height if no 3D data, that would create a false height of 3 meters for all other buildings. It would create closed surfaces that we could scale, but it's sort of like, do you want to rebuild them by scaling them, or do you want to rebuild them in this way? So it could be a pick your battle sort of situation. Just out of curiosity, before we get to this one that's being projected underneath this topography surface, we're just going to see if this building is going to work. It is closed. I don't know if it's planar. Yeah, this is also not going to work. So I think we basically would probably need to project all of these to C-plane, delete input object, and then extrude them. That's kind of a lot of work, honestly. But, if that's the game you want to play, you could totally do that. Depends on how accurate you need these things to be. Since we did project this to C-plane, we can go ahead. I'm actually going to turn off a few of these layers. So we're going to turn off the outlines and the topography. So we're just looking at the building heights. I'm going to use this building as a reference for moving this up. So I'm going to use the move command. And if you remember from last time, we'll use the vertical constraint. So we're going to enable that. Our base point could be really any point here. So I'll pick this one. And I'm just going to snap it up to reference this building height. And you could see from the CAD Mapper file, if I quickly toggle this back on, some of these buildings were clipping the surface. I seem to have used an average height for the building and then just let it kind of clip the rest. So there's enough inaccuracy in this model that I think we can be a little okay with this. So I'll just turn that off. Okay, now we should be able to use the ExtrudeCrv command. Here we go. I'm going to change my current layer to buildings layer. Right now it's default, so I'll just make it building. So the stuff I generate will be already on that layer. And now looking over at my image, this building appears to be 16 feet tall. So I'm going to go ahead and type in 16, press enter, and then there we go. With ghosted viewport, it can be a little hard to see if this is actually capped or not, so I'll just put it up back to shaded. And there you can see we've got a nice shaded, closed surface. Apparently my cat wants to say something. So we're going to go ahead and change that object layer to the buildings layer. Lavender is quite chatty tonight. So sorry about that. So this could be one of those things that takes a while. If you're okay with the level of precision, or if you're okay with going back and then adjusting the building heights with the gumball, there's a workflow I can show you. So, if you're okay with that clipping a little bit, just so that it's more or less sitting flat on the surface. The surface is sloping, so it's never going to be completely flat since it's a flat bottom and a curved surface. So anyway, if you're okay with that, I will show you a method for quickly creating all of these buildings, like, at least the ones that we have that building height data for, without too much trouble. So I'm going to go ahead and hide the topography layer. And I'm actually going to create another building footprints layer. Building footprints. All right, and then this will be, we'll say 3D buildings. Okay. My thought process here, I'm going to actually turn that other contours layer and the parks off. So we're just dealing with the footprints and these extrusions. So my thought process here is we're going to put all of the 3D buildings, those are fine to stay. For the rest of these lines, we're going to move that to the building footprints layer. And I'm actually going to make this like our kind of construction geometry color. Okay, now you could spend all day individually clicking and selecting all these, or I'll show you a very nice command to know. If you ever want to select a specific type of object, there's usually a command for that that starts with SEL for select, and then see, look at all these commands we've got. But we only really care about curves in this case. So we're going to say SelCrv and then press enter. It will automatically select all of the curves that are currently displayed here. And now we can quickly change that to our building footprints layer. Boom, easy. I'm just gonna hide our building 3D buildings for now. Now these are still going to be in different heights, right? Like up and down. For this workflow, for extrude curve to work, we need them to be flat and projected to the C-plane. So that's exactly what we'll do. Go ahead and select everything. And then we'll type in project to C-plane. Delete input objects, yes. And you see some of those just, well, they probably should all have jumped down. Now, just to confirm before we go down a rabbit hole of whether some of these are open or closed, we're going to use another select command. So it'll be SEL, and then in this case, open, and it's already filled it, open curve, open CRV. So press enter. And oh, this is great. No objects added to selection. So that means that all of these are closed curves. So we shouldn't have any trouble extruding them into a solid object. All right, so now this could be a time where you want to, go back and forth and reference this image quite a lot. It can also be a little tricky. So I think I'll turn these layers back on since we kind of have our bearings set with these. Now you'll notice, like, it's okay if these, orange buildings are up in space. I think what we'll do, my thought process is we'll extrude these buildings the height that we know they should be, and then later, after we've extruded them all, we'll set their height with the gumball relative to our topography surface so that it's more or less correct. Yeah, I think that's the most logical sort of way to do this. So rather than doing extrude this one building, set the height, go back, I think part of this, and this is a good way of demoing this, is finding workflows that are kind of grouped by process type. So, doing all your extrudes at one point and then moving all your gumball things at another streamlines that production. So we don't want to be here all night. So, all right. And don't worry, I'm not going to do these all. I'll just show you a few. So we've got I think this is the little police substation, this little 10-foot building. So I'll just do extrude curve. First, let me toggle my current layer to 3D buildings. Now we can do extrude curve. And since we're going to be doing extrude curve so much, I won't bother typing it in each time. I'll just use enter or spacebar to bring up that previous command. And then, it's just going to be 10 feet for that one. On to the next. This is going to be 15 feet. So there we go, 15. Excuse you. This far one, we can see this is 18 feet. So extrude up to 18. And you can see this isn't going to take forever, right? It's not going to take too long. Now, we don't actually have data for this one. So I'm just going to make it up. I think it's probably, I can't even tell that one. Probably that size. Yeah. All right, now then we've got this one across central. I think this is a building. This is going to be our 12-foot. And then the next one next to it is 15. And then we don't have data for that. I think this one is just the one that's 20 foot. Alrighty, so you'll notice that some of these building heights are a little bit inaccurate, right? So like specifically this one, if we were to just extrude this like our 29 feet, for instance, like that would be the highest point, we're gonna have a series of these sort of roof lines that are very like simplified. And you know, if we really needed this level of detail, here's how I think I would suggest going about creating that detail and more accuracy. So we're going to go ahead and delete that extrusion. Now you'll sort of notice, even in perspective, this building footprint is not orthogonal, and especially if we go to top view. It's also not, as most buildings are, not fully on our north-south axis. So we've got some wonkiness that we're dealing with. Now, how much we care about this wonkiness is definitely up to your project, but I'll show you a sort of fast way that preserves some of the detail here that might be important. So we're basically going to trace around some of the sub areas of this so that we can individually extrude these different building heights. So I'm going to use the polyline command. And we're going to start, first I'll toggle my current layer to the building footprints. Great, so now I think we'll just do this like kind of squarish section that seems to be the highest point here. So we're going to do our best to follow this existing footprint. Now this is where our tab constraint can really come in handy if we're having trouble snapping to the sort of non-orthogonal angles. In this case, I think I'm okay without tabs. So I'm just going to click there. And that's snapping, that's okay. This is where I'm going to consider using tab here. So the goal is to create a point here that's in line with this point. And to do that, I'll just hover so I get that smart track node. I'm going to drop this down, and you'll see it's going to be snapping so that my next point can intersect that, and it will match my next, like it will be more or less parallel with that secondary line over here. So let's see here, again, following that, there we go. So I'm going to click there, and now we can finish this command by coming up and closing it there. Now we should have, yeah, here we go, this separate closed curve on that, following the kind of wonkiness of that building. So I'll just go and continue this for this middle building section. If you're being super particular, we could bring in a reference photo and scale it. Or if you're being a little loosey-goosey, I think I would probably be fine with kind of guessing. I'm going to say this is probably a 30-foot wide building for this little section here. That's probably on the narrower side, but we'll see how that looks. So I'm going to continue with this. Ooh, and you'll notice there's still this little wonky. So I'm actually going to click here and then click here because it's not a fully straight line. All right, now here's probably where I'm going to use tab. So I'm going to hover over here to get my smart track snap so that it's snapped to that very bottom corner. Now I'm going to press tab. So now it's going to lock that in this wonky line. Okay, now I can enter a distance constraint from, this is the point, the last point of my polyline. So I'm going to say 30, and yeah, and that's looking a little narrow. This might be closer to 50. Yeah, and that's more or less right. Maybe it's 40. Maybe it's 40. Yeah, I think we'll be okay with 40. So I've still got my tab constraint, so I'm going to click. I'm going to click there to define my next point. Oh gosh, and you'll see sometimes it'll snap to something you don't want. So I'm going to undo that and still left my last active point. So you can always do Control-Z within the polyline tool to just undo the last point you clicked. And I'm actually going to double tap Control and get rid of these extra smart track things because they're kind of throwing me off. There we go. Now I'm just going to snap here, press my tab constraints. There we got 30 feet, or they got our locked on that angle. Now I'm going to type in 30. oh, sorry, it was 40. I think we determined 40 feet. Goodness gracious. Okay, this is really throwing me for a loop. Okay, we're gonna type tab. 40. Okay, there we go. You see, sometimes Smart Tracks is too smart. I'm actually going to click this next point without it being on the node, but you can see how it's snapped to that area right on the line. If I click here, it's going to put that point 40 feet away. I think what was happening is I was referencing too many points, and that smart snap was having trouble finding out. So yeah, just you'll get a little preview by seeing that like pink node. So for example, if I'd done like 30 feet in this direction and pressed tab to lock that, you can see if I hover my cursor over on this side, since I've got my other constraints keeping this line in place, I don't necessarily have to click right here where that is, as long as I click where that pink node for the endpoint is. Hopefully this is making sense. So in this way, I was able to click on the corrected distance, but I wasn't actually on this line because it was wanting to snap somewhere else. Anyway, so I'm just going to keep continuing up here. And I think this intersection is fine. And then I'll end this polyline right here. Okay, cool. And then one last one. This can be easy. So we're just tracing here, 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 and back home. Great. Okay, so now we should have our original line that we created with that was created by CAD Mapper. We've got our different curves. And now you'll see if these curves are stacked directly on top, you'll see these two different selection options. So you can pick which one you want to select, right? So, and we should have this other one. Great. Okay, so that's all to say. We're just going to extrude this first one up 29 feet. Second one, second one is going to be 22. And our third one is going to be 13. All right, that was kind of a long walk to go for maybe not all that much gains, but just going to change these to the 3D buildings layer. That's in essence how I think I would recommend using those original building footprints to get a general outline of the building, and then further adding those levels as you see fit. And I think we've done a pretty good job, right? Like that's, like if we kind of look there, that's more or less right. Perhaps there's one extra level that we're not getting, but I think if you're looking at an urban scale, unless that's like a skyscraper, I think this level of detail is fine. Okay, so that's how I would go about creating those building footprints. Again, I would, if you had other data from Google Earth, you can use those for the rest of the building footprints. For now, I'm not going to worry about them. And we're going to toggle our topography layer back on. And now we'll see that a lot of these buildings are fully underneath our topography. To make our lives easier, I'm going to enable the 3D building layer as our current layer. I will actually turn off the building footprints layer, and I'm going to lock the topography layer so we don't accidentally move it around. Okay, now we'll go to our viewport display mode and change it to ghosted. This can make selecting these buildings way easier. And let's start with this first one we did here. Just zoom select it. So I'll just use the gumball to bring this up roughly to the right height. Unfortunately in Rhino, there's not a great way of placing this directly on this surface because the surface has a lot of variation. It would, in a sense, it's always going to be somewhat arbitrary because we're going to be selecting a flat building on a curved surface. So it's like, what point is, that bottom layer? So hopefully that's making sense. So moving on to this substation, let's see, it's kind of clipping there a little bit. For these large scale urban design sort of things, this is going to be more than enough. If we were building a CNC ready file, we would have a different approach for this, certainly. And by CNC ready, I mean, if we were to make a physical model using this geometry, using the Fabrication Labs CNC router, we would probably need a different way of attaching these buildings so that we could route out the building footprint, basically subtracting it from the topography. So we could then add a 3D printed building instead of like where that outline is. The CNC router is great for kind of creating these broad surfaces and pocketing out these building footprints. It is not the best tool for creating these buildings because the limitations of the tool just can't handle this level of detail. But it would be a great thing to then 3D print. Luckily, you could take these buildings right now and export them to be 3D printed in a matter of minutes. So modeling in Rhino using closed surfaces and closed poly surfaces enables 3D printing to be a really fast workflow. So that's one of the reasons I really like Rhino for this. And this one is clipped out a little bit. We might be going too far. I'm trying to like intersect so it's not just floating in midair. Okay, it's looking pretty good. So yeah, it hasn't taken too long. I've been going at a tutorial pace, so we're about a little over 40 minutes going through, maybe 50. If I was doing this real time, I would probably have done this in like 15 minutes. So this wouldn't have taken a huge amount of time. I think going over those steps again, ProjectToCPlane from the original source geometry, splitting the 2D and 3D into different layers, using a Google Earth measurements to create your accurate heights by extruding and then placing those with the gumball. If there are existing buildings that need a slight adjustment, you can use the scale 1D command to quickly set that new scale. And yeah, I think also just like helping, we'll turn all these layers back on, helping you see what's happening with changing some of the layer color display modes is super helpful. So there you go. It's as easy as that. I say that now, but Okay, so CAD Mapper, great resource. Can be a little finicky with buildings, especially if you're going for a higher accuracy. And if we were to re-download this with the 3-meter default for all the stuff that didn't have it, we might be fine with that level of abstraction. If that was the scale of our topography, totally project dependent, right? Using some select commands to quickly select different types of geometry, right? So SelCrv, CRV, be able to quickly select all of those building footprints. Making sure your contours layer is off. So yeah, SelCrv and SelOpenCurve, just to double check that there's no open curves that would prevent us from creating closed surfaces from a extrude curve, and some other things. One other thing I'll show you real quick. If you wanted to create this as like a surface right now, this park, we've got the border. There's a command called PlanarSrf, PlanarSrf. We'll create a surface. Okay, right, from a closed planar surface. So this is closed, but I believe, it's closed, but it is not planar. So we could do ProjectToCPlane real quick. Then we could do planar surface. And then assign this to the parks layer. And that's how you could create a surface from an outline without creating a volume. It's just a surface. So if that's something you wanted to represent a little bit more accurately, that's how you could do that with this surface. There you go. Planar surface. Great. So that's a modeling workflow using CAD Mapper. How to open a new project, set your units, either open a different unit type and change your units to be what you're wanting, how to verify that the scale is set correctly, how to generate these 3D forms from those 2D building footprints, etc., etc. And then just for fun, we could put this on our render mode, and we can see there we go. Starting to look like a model now. So good stuff. All right. Hopefully this is helpful. Go ahead and play around with this, and happy modeling.